Hello everyone, my name is Diksha and I am from the Bodhi Academy. So today I will continue with electrochemistry chapter which I had left the last part. So let us start today with conductance and electrolytic solutions. Now in electrochemistry we have we have ions, okay, like we have electrolytes. So electrolytes gives ions. So since there is an involvement of ions, there is a conductivity in the solution. Okay, now what is conductivity? When they conduct electricity, or when ions are capable, ions have tendency to conduct, so that is called a conductivity. So here there are two main terms, that is conductance and resistance. So as we know that resistance formula is R is equal to rho L by A, or we can say that resistance is directly proportional to length by area. Okay, or when you remove the proportionality sign, we get R is equal to rho L by A. Okay, now what is this rho called as? Rho is called as a resistivity, which is a constant. Okay, so rho is called as a resistivity, which is also called as a specific resistance, and its unit is ohm meter or ohm centimeter. Okay, then if I try to write this in terms of conductivity, then conductivity is denoted by G. So conductivity is equal to 1 by R, that is 1 by resistance. And R, we know that R is equal to rho L by A. So 1 by R will be equal to what? This all A will go above and this rho and L will come down. So we get A by rho L, and 1 by rho is equal to K, that is conductivity. That's why in place of 1 by rho we have written K, A by L. Okay, this is the equation for conductance in terms of conductivity. And conductivity is also called, in Greek it is called as a kappa, that is it is denoted by K. Okay, so now here what is important in this part is how the variation of conductivity and resistivity takes place. Okay, so conductivity, when electrolytes are added in water, they furnish their own ions in the solution, hence conductivity also increases. And conductance depends conductance or conductivity of the solution depends on nature of the electrolyte added, meaning if you add strong electrolyte or weak electrolyte, so it depends on that. Okay, so you cannot add any type of electrolyte. So uh, the electrolytes which you add, it depends on that. Then size of the ions produced and their solvation. Okay, if the size is small or it's large, so it depends on that. Nature of the solvent and viscosity. Okay, nature of the solvent means whether it can flow easily or whether it is thick, so it depends on that. And concentration of electrolyte means how much concentration it is having, low concentration, high concentration, and temperature. Okay, meaning conductivity increases with increase in temperature. Now we will see about measurement of conductivity of ionic solution. So here is a setup which is done. Now here what is done, this is a here we are having two different types of conductivity cells. So this experiment you will have in higher classes, not in this 2 years, because uh, this is yeah, physical experiment which will tell you about the conductivity cells. So here we have unknown resistance, that is R, and a measuring resistance of ionic solution. We face two problems. Passing the direct current DC, okay, changes the composition of solution. If you pass direct current, it will change the composition of solution, but solution cannot be connected to the bridge like metallic wire or other solid conductor. So this was solved by using AC, that is alternating current. And second problem is solved by using specially designed vessel called as conductivity cell. This is conductivity cell. So it consists of two platinum electrodes coated with platinum black, and these have area of cross section A and separated by distance L. So that's how we get this equation, that is R is equal to L by R is proportional to L by A, which is equal to R is equal to rho L by A, which is also equal to 1 by Ka. Then the quantity L by A. L by A means what? Length per unit area. So this is called as cell constant. Okay, now L by A is called as cell constant. denoted by symbol G star or G abstract. It depends on the distance between electrodes and the area of the cross section. Okay, so based on this we have this equation: K is equal to cell constant by R, which is equal to G star by R. So based on this there are some problems which are asked. So you all can put the values which are given and find the value which is not given using that. Okay, now we will see the variation of molar conductivity. First of all, formula of molar conductivity. Now what is molar conductivity? Molar conductivity is in terms of particular molar concentration. Okay, now normal conductivity is anything that we take, but the concentration of ions or ease with which ions move under potential gradient so becomes necessary to define physical meaningful quantity called as molar conductivity. So molar conductivity is, it depends on the concentration. So lambda m, which is equal to conductivity per C. C means molarity or concentration. Okay, so lambda m is given by this final equation, that is K into 1000 by molarity or by C. This is a very important equation on which problems are asked. Okay, then we will just see one problem based on this. Electrical resistance of a column of 0.05 mole per liter NaOH solution of diameter 1 cm and length 50 cm is 5.55 into 10 raised to, here there is into 10 raised to 3 ohm. Calculate its resistivity, conductivity, molar conductivity. Now resistivity means rho, so you have to put rho formula, and what is given here? Electrical resistance, so R value is given. Then diameter is given, that is 1 centimeter. Length is given 50 centimeter. So L is 50 centimeter, which is converted into meter over here, and area is pi r square. Okay, a value directly it is not given, but we know the formula, that is A is equal to pi r square in terms of sphere. Then here what we can do, R diameter is given, so diameter means what? Diameter is equal to 2r, right? So r is equal to d by 2. So diameter is 1 by 2 is 0.5. So that's why 0.5 is the diameter taken over here, and the value for area is 0.785 centimeter square. Now you have to find resistivity. So rho is equal to RA into N. R is given, resistance is given how much? 5.55. So that you put in place of R. A we found out 785 and divide by 50, which is given here, length is equal to this much. Now this is the resistivity, that is rho value. Then by using resistivity we can directly find conductivity. How? We know that conductivity is reciprocal of resistivity, so you can write K is equal to 1 by rho, which will give you this value 0.01148 Siemens per centimeter. And last is molar conductivity, in which we just have to use the K value and other things are given. So K is this value which you have to put into 1000 by C. Now C is the concentration, which is this. Okay, 0.05 mole per liter. So C value we can put here and we will get the answer as 229.6 Siemens centimeter square per mole. Okay. Now we will see, this is very important concept, variation of conductivity and molar conductivity with concentration. Okay. Now both conductivity and molar conductivity, they change the concentration of electrolyte, and conductivity decreases with decrease in concentration. Okay, conductivity decreases with decrease in concentration. Now why this happens, that we will see. Okay, so here conductivity is what? Conductivity is, okay, this is conductance, which is equal to K A by L, right? If A and L are unity, unity means if their value is 1, then conductivity is equal to conductance, right? So here what happens, number of ions per unit volume that carry the current in the solution decreases on dilution, meaning conductivity, when you carry out the when you carry out the experiment, what happens, number of ions per unit volume decreases, meaning if I have suppose 10 ml of solution, okay, and in that I have put some amount of salt, suppose 5 gram of salt I have put, okay. And then later on, after dissolving this salt, again I have added some 50 ml of water in that, okay. Now when I add 50 ml of water, ions number is not going to change, only what will change, the volume will change, right. So number of ions per unit volume will decrease, okay, meaning the ions were in the ions in 10 ml, okay, the number of ions which were there in 10 ml were more, okay, were more means same number of ions were there but area was less. But here when you add 50 ml, area is more now, so ions per that much of area is decreased, so that's why conductivity also will decrease. So conductivity is the conductance of 1 unit volume between the two platinum electrodes. So what happens when area of cross section, okay, so conductivity K is equal to L by A, G L by A, okay, K is equal to this G L by A. So length, area, right. So area means what? Area means the volume, the concentration is due to the conductance of 1 unit volume, right. So what happens here, when you increase the area means when you keep on adding the more and more solvent, okay, or when area is increased, when ions are decreased per that much of area, then you can see that by this equation conductivity is inversely proportional to area. So when area increases, conductivity decreases. So we can apply this concept here, that conductivity decreases with decrease in concentration. As dilution increases, area also increases, so that's why conductivity decreases. Now next, molar conductivity. Molar conductivity on the other hand increases with decrease in concentration, okay. Molar conductivity increases with decrease in concentration. Now how molar conductivity decreases, that we will see. Molar conductivity is what? Lambda m is equal to K into 1000 by C, okay. So K into 1000, K is conductivity, C is what? C is, we can write, C is molarity, so I can write it as N2 by V. N2 by V is number of moles of solute per unit volume into 1000. Now V I can take here, V I can take above in the numerator. So this will give me this equation, that is lambda m is equal to K into V. Okay. Now from this equation we understand that lambda m, that is molar conductivity, depends on the volume, okay. So if it depends on the volume, on dilution volume increases, so when volume increases, what happens, molar conductivity also increases with that. So that's why molar conductivity increases with decrease in concentration, that is increase in volume, because total volume containing 1 mole of electrolyte also increases, okay. Now this is a graph in which they have shown molar conductivity versus the concentration of acetic acid, that is weak electrolyte, and this potassium chloride, that is strong electrolyte, in the aqueous solution. So when during exam, if they ask about graph, to draw the graph, then they might ask about one graph here, like either weak electrolyte or strong electrolyte. So what you have to do, if strong electrolyte is asked, only the graph of KCl you have to draw, that means this line. And if they ask about acetic acid, then you have to draw this curve, okay. So these things you have to keep in mind. Okay. Now next term we are going to see here is next term is limiting molar conductivity. Now what is that? When concentration approaches 0, molar conductivity is known as limiting molar conductivity. When concentration approaches 0 means when it is infinitely diluted, okay, meaning when you don't when you have traces of that salt or the solute which you have put, and when it approaches approximately 0, it is called as limiting molar conductivity. So now what strong electrolytes? Now what are strong electrolytes? Strong electrolytes are the one which dissociates completely in the solution, okay. So about strong electrolytes, this is one equation that is given by lambda m is equal to E naught m minus a c raised to half, okay. This is the equation which we have to put. Now Based on this, these are the electrolytes which are known as 112122. Now why these are known as this, why they are denoted by this? Because NaCl, Na is, in NaCl we have Na plus 1, Cl minus 1. In CaCl2, okay, Ca is 1, Ca is of Ca is having plus 2, Cl is having minus 1, but these are 2, okay, so minus 2. So you can see that 1 Ca and 2 Cl are combining, that's why it is, now this Ca is having 2 charge, Cl is having minus 1 charge, so that's why it is 2 1. And MgSO4 both are having 2 2 charge, that's why it is 2 2, okay. Then next important, this Kohlrausch law, which tells that uh, the limiting molar conductivity of an electrolyte can be represented as sum of the individual contributions of anion and cation. Okay, now this we will understand through one simple example of NaCl. Okay, so molar conductivity of NaCl is given by molar conductivity of its sodium ion, that is a cation, plus molar conductivity of chlorine ion, which is the anion. Okay, so we can apply this to any electrolyte, that is if we apply this to any NaBr, okay, that is E naught of M of NaBr, then which two ions will come into picture over here? Lambda naught of Na plus and plus lambda naught of Br minus. Okay, so whatever ions you have, those ions will come in from the electrolyte, and that is the statement of Kohlrausch law, that it's very simple, that molar conductivity of an electrolyte represented as a sum of individual contributions of anion and cation of the electrolyte. Okay, next, weak electrolytes. Weak electrolytes are the electrolytes which will not dissociate completely, and based on that we have this equation, that is degree of dissociation. Okay, from this we know how much extent they will dissociate, and in what is the equation? Alpha is equal to lambda m by lambda naught m. Lambda m is a molar conductivity, lambda naught m is a limiting molar conductivity. Now based on Kohlrausch law we have these problems, okay, that we will see. Calculate the limiting molar conductivity of CaCl2, calcium chloride and magnesium sulfate. So here how to do this? Calcium is having plus 2 charge, this is having minus 1 charge. So we combine calcium, we have to combine for CaCl2, what we have to combine? CaCl2 means what? 1 calcium and 2 chlorine. So we have to combine lambda naught of Ca2 plus lambda naught of Cl minus. We cannot take 2 over here or Cl2 over here, because Cl exists in this ion. So we have to do 2 into lambda naught of Cl minus. So these values they are given in the table, but we will see directly over here. Calcium value is 119 Simon centimeter square per mole, and 1 chlorine value 76.3 Simon centimeter square per mole. That we have to multiply, and we get this value as the according to Kohlrausch law. Okay, that is molar conductivity of calcium chloride. Similarly, we have to find for other elements. So here this is one different type of problem in which molar conductivity is given of NaCl, HCl and sodium acetate, in which these are the values given, and calculate the lambda naught or molar conductivity of this CH3CO acetic acid. Okay, so here what happens? NaCl, HCl, NaAC meaning sodium acetate, they are given. Now you have to see which, now CH3COOH contains 2 ions, right? CH3COOH and H. So you have to see the formula, or see the compound in which there is CH3COO and H. So in this, where is CH3COO? CH3COO means AC. So here we have CH3COO, and where we have H, in this we have H. So we can combine this both here. Okay, we can combine this both. So after combining, what we will get? We will get individual ion H plus and individual ion AC. And then you have to subtract the other compound or other salt in which there are these 2 ions, okay, these 2 which are not used. So that you have to subtract and put the values and get the answer. Next part is electrolytic cells and electrolysis. Now here in an electrolytic cell, external source of voltage is used to bring about a chemical reaction. Okay. Now here we are not using chemical reaction to carry out the reaction. Using not chemical reaction, we are not using to produce electricity, but we are doing opposite. We are taking the electricity and carry out the chemical reaction, especially non-spontaneous reaction. Then here, based on that, we have qualitative aspects of electrolysis based on this Faraday's laws. So Michael Faraday was the first to describe quantitative aspects of electrolysis. So we will see Faraday's law. First law. What is Faraday's first law? Amount of chemical reaction occurs at any electrode during electrolysis by a current proportional to the quantity of electricity passed through the electrolyte. Meaning, um, the amount of chemical reaction that takes place at any electrode, it will depend on the electricity that you have passed through the electrolyte or the solution. Okay. Then second law, amount of different substances liberated by same quantity of electricity passing through the electrolytic solution proportional to their chemical equivalent weights. Meaning, which substances we are liberating as ions, okay, by the same quantity of electricity. So they are proportional to chemical equivalent weight, that is atomic mass of metal and number of electrons required to reduce the cation. And it is given by this equation, Q is equal to IT, okay, where Q is charge, I is current and T is the time. Okay. So here the amount of electricity required for oxidation and reduction depends on stoichiometry of the electrode reaction. So if you see this reaction, silver plus silver electron gives silver. So we know that one electron, charge on one electron is 1.6 into 10 raised to minus 19 coulomb. So charge on 1 mole of electron will be what? So charge on 1 mole of electron will be 6.022 into 1.6 into 10 raised to minus 19. That will give you 96487 coulomb, which we write as 96500 coulomb approximately. Okay, which is Faraday's constant. Then products of electrolysis. Here the most important part is they ask about molten NaCl. The products of molten NaCl. So if you use molten NaCl, products of electrolysis are what? It is sodium metal and Cl2 gas. Okay, we can see here. Um Product of electrolysis in sodium. Here when we react sodium and hydrogen over here. Okay, so at cathode what happens? NaCl, sodium chloride, reacts with water to give Na plus Cl minus, and an anode chlorine will give half Cl2, meaning chlorine will gain electron to give Cl2 gas, and net reaction is this NaCl plus H2O, that is water, gives Na plus OH minus and half H2 and half Cl2. Then about batteries. Now what are batteries? So it is a source of electrical energy, basically a galvanic cell where chemical energy of redox reaction is converted into electrical energy. Okay, so first of all we have primary batteries. Now what you need to know about primary batteries, that they are one time use, meaning once you use them you cannot recharge them and use them. Okay, so use and throw kind of, so reaction only once after use over a period of time and becomes dead and cannot be reused again. So one of the most important example of primary batteries is dry cell. Okay, dry cell, which is also known as Leclanche cell, from which diagram is asked, also reactions are asked. So at anode what happens? Zinc loses its electron, two electrons to produce zinc ion, and manganese dioxide, it combines with ammonium, gains one electron to form MnOH, okay, and NH3. Next is mercury cell, same like this. So it is used in hearing aids, watches, consist of zinc mercury amalgam as anode and paste of mercury oxide. The diagram is not that important because it's not asked in exam. Next is secondary batteries. Secondary batteries means which can be rechargeable, okay, that we use in inverters, generators, then your cell phone, uh, so which we can recharge basically. So secondary cell after use can be recharged by passing current through it in the opposite direction, okay. So here we have one important example, that is lead storage battery, which is this. Here it is shown. So what happens here, secondary cell after using can be recharged by passing current through the opposite direction, so it can be used again, and good secondary cell can undergo large number of discharging and charging cycle. So here lead storage battery is a very important in terms of secondary batteries, commonly used in automobiles and inverters, and consists of lead anode and grid of lead packed with lead oxide and as a cathode. So here you will see what happens at anode. Anode lead combines with sulfate ions to give lead sulfate and release two electrons, and at cathode lead dioxide and sulfate ion when combined with hydrogen ions plus two electrons, it gains two electrons to give lead sulfate and water molecule. So overall reaction is shown, lead plus lead dioxide gives sulfuric plus sulfuric acid gives lead sulfate and water molecule. Okay, so this diagram is asked mostly in the exam, okay, but no need to draw in this way. You have to draw just this down part which is shown over here, and you can just label them, okay. This is most commonly asked diagram. Next is nickel cadmium cell, which is also a secondary cell. Using it is more expensive to manufacture, so that's why there is not much information given here of this cell, okay. Then next important cell is fuel cell. Fuel cell, this is hydrogen oxygen fuel cell, and is called as H2O2 fuel cell. Now here, why we use this, we are using this to produce water, okay. So what happens here, production of electricity by thermal plants is not very efficient method, so here major source of pollution. So chemical energy of fossil fuels used for converting water into high pressure steam used to run a turbine to produce electricity. So who does that? Like galvanic cells, which are designed to convert energy of combustion fuels like hydrogen, methane, methanol directly into electrical energy, they are called as fuel cells. So these cells convert their energy directly into electrical energy. Now what happens here, in this H2O2 fuel cell, which was used in providing electrical power in Apollo space program, water vapor is produced during the reaction, condensed and added to the drinking water supply for astronauts, meaning the water molecules which were water vapors which were produced after condensation, they were added to the drinking water supply for astronauts, and hydrogen and oxygen are bubbled through the porous carbon electrodes. So catalysts like finely divided platinum, palladium are used as a catalyst for the reaction. So here what happens, at cathode oxygen combines with water to give OH minus, and hydrogen combines with OH minus ion to give water and electron. So overall reaction is H2 plus O2 gives 2H2O. So here application type of question also can be asked, like draw the diagram of cell which was used in Apollo space program. So that's why you should know small points about these cells, okay, because directly they cannot ask like draw the diagram of H2O2 fuel cell, so you should know some points about them. Next is corrosion. Corrosion means what? As you have studied in our lower classes, it's the oxidation of metals like iron, copper. So iron after oxidation, we can see brown color layer is formed on the iron, that is rusting, and on copper green color layer is formed, on silver black color layer is formed. So these all are examples of oxidation or corrosion. Then corrosion, what are the side effects, or what are the damages caused by corrosion? Causes enormous damage to buildings, bridges, ships, and to all objects made up of metals. Then what happens at anode and cathode during corrosion, that is given over here. So yeah, at cathode oxygen combines with hydrogen and electrons to give water and overall reaction. At anode, the ion loses its electron. That ion undergoes oxidation, which is Fe2 plus 4 electrons. And overall reaction is when ion is exposed to air, moist air or oxygen along with uh, this ions, you get Fe2 plus, that is Fe in the form of ion and water molecule. Okay, so this is about corrosion, which is the last part of this chapter. Okay, so now we will discuss one problem based on this. Now, as we know that 1 mole of electrons require this much of coulombs electricity, okay, to pass. So this, if you take this reaction, magnesium Mg2 plus 2 electrons. So here, how many electrons are involved? 2 electrons are involved. So since 1 mole of electron requires 96500 coulomb, 2 moles of electron will require 2 into 96500. So 2 into 96500 coulomb per mole. Similarly here 3 into 96500 coulomb per mole. Okay, so this is how we have to solve this. Next, we will see this problem. A solution of copper sulfate electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of mass of copper deposited at the cathode? So time is 600 second and charge is um, time is 600 second. Time is one. Current is 1.5 ampere and time is 600 seconds. Okay, and charge is 900 coulombs. According to the reaction, copper is electrolyzed. That means copper will undergo this reaction. Copper will gain 2 electrons to give copper. Okay, so since they have mentioned cathode we have to take this reaction, gaining of electron. We require 2F or 2 into 96487 coulomb, meaning since 2 electrons are involved, we need this much. Deposit 1 mole or 63 gram of copper. So for 900 coulomb, okay, now they have given what, 1.5 amperes. So 1.5 amperes means what? Q is equal to, what is the equation that we have? Q is equal to I into T. T is given 10 minutes, right? So 10 minutes into seconds will be 600 seconds. Current is given 1.5. So 1.5 into 600. That's why we get Q is equal to 900 coulomb. Okay, so this we can substitute here. So we require 2 Faraday. So for 900 coulomb, mass of copper deposited is how much? So we have to see for 96487, 1 mole or 63 gram of copper. See, for 1 mole or 63 gram gives is deposited for 1 mole, that is 2 into 96487. So how if you have 900 coulomb, how much of mass will be deposited? So you have to cross multiply and get the answer. So this is the answer that we get after cross multiplying this. So 0.2938 grams of copper will be deposited on the cathode. Okay. So yeah, from electrochemistry chapter, what is important? First of all, you need to know about galvanic cell, that is Daniell cell. Problems are asked on Nernst equation, then equilibrium constant, Gibbs free energy. These are most common problems or most frequently asked problems which we have to practice and solve. Then we have also molar conductivity, normal conductivity, which is asked. Then graph of molar conductivity variation. Then reactions. Okay, batteries, primary batteries, secondary batteries, their anode cathode reactions, then variation of molar conductivity with dilution, then variation of conductivity with dilution, Kohlrausch law definition is very important, and then its use, degree of dissociation, and batteries, secondary batteries, primary batteries, and their diagram. Especially diagram will be asked in case of dry cell, lead storage cell, and H2O2 fuel cell. Only three diagrams can be asked, other diagrams are not there. Okay, so and their reactions at respective cathode and anode are very important. Okay, so with this we have discussed electrochemistry chapter. So in next video I will discuss other chapter from physical chemistry. Okay, so yeah, thank you.